This is lesson 3.4, and we're going to be learning about compound interest in this problem. So just a little background on this: when you go and deposit money in a bank account, or if you put it into stocks or some kind of an investment, the way that you make money on that is you are being paid for somebody else to use your money while you're not using it. And so that's called interest. And so the way that that works is, I'll just take a very simple example first off. And let's say that we have $100 and you're paid 5% interest annually, so every year. So the first year, or when you first put it in, you'll have $100. And then after year one, you're going to have $100 plus 5% of $100. So 5% of $100, or $5. So that's going to give you $105. Then the next year, you're going to get the $105 plus you're going to get 5%, but it's going to be 5% of $105. And so that's going to make it different. So what compound interest is you get interest on top of what you already have interest on. So I'm not only getting interest on my original $100, I'm also getting it on the $5 interest that I earned. So that's how it grows exponentially, because it's growing on money that you didn't even have before. And so we're going to be talking about exponential growth with compound interest. So a couple of things before we start. First off, compound interest, it is only used if you are talking about money. Okay, so it's not talking about when we're talking about bacteria or mice or any other type of question. It's only if you're talking about money, and it is only if it says the word compound in the problem. It has to say the interest is compounded. So if those two things don't happen, you are not going to use this formula. The compound interest formula is right here, and it looks pretty complicated. It's really very much the same as the ones that we're used to. This A, that's our output, and that's the amount that we have at the end of the problem, so the total value after it's all said and done. The P is what we call principal. I guess I don't need to write that, it's right here. So P is the principal, or the initial value, and so principal is like when you're talking about how much you're putting in an investment. That's what we're talking about, the principal amount. The 1 in the problem is because you have the money you had. So in the example I just showed you where you had $100 and you had $105, you still got to keep your $100, and then you added to that. So that's what the 1 does, is it's the 100% of what you already had. So you're going to keep all of what you had, plus you're going to get something else. The next part is what's different. We're not just going to have R, but it's R divided by N. So R is still our interest rate, and don't forget you're going to turn that into a decimal. But the thing here is the N is going to be how many times it's compounded in a year. So for example, we've got this table over here on the right that tells us what all of these words mean. So let's just take quarterly, for example. So there's 4 quarters in a year. So January, February, March is 1 quarter. And so if we say that we get, I'll take an easy number, 10% interest, and it's compounded quarterly, that does not mean that at the end of March you're going to get 10% interest, and then at the end of June you're going to get 10% interest, and then at the end of September you're going to get 10% interest, and the end of December you're going to get 10%. That's not how it works, because that would be a lot of interest, okay? But what it does is they're going to take that 10% and they're going to divide it into 4 pieces, and they're going to give you 1 piece in March, 1 piece in June, 1 piece in September, and 1 piece in December. So you'll get just 1/4 of that, so 2.5% is what that would be, or 0.025. So you just get a little piece at a time. You don't get it all together. And so that's the thing with the R divided by N. You're going to take the interest rate and you're going to divide it into a certain number of pieces. Now, taking the example I just gave you, if we've got quarterly, so we have 4 payments in 1 year, that means that you're going to get paid in 1 year, you're going to get 4 payments of interest. On the other hand, if it was compounded monthly, then you're going to get 12 payments of interest. And so in 1 year, you would get 12 payments. So we would take the 1 year and you have to multiply it by 12. If it was 2 years, you would multiply that by 12, so you'd get 24 payments. And that is what the N times T as the exponent is. So when you see the N, that's an important number, because it's going to tell you how many times you're going to get that payment over the course of 1 year. One other thing about compound interest is our time is always going to be in years. It's never going to be in months, it's never going to be in days, it's always going to be in years. It might be compounded monthly or weekly or daily, but it's always going to be time is in years. So let's start with a problem. An investment of $500 is compounded monthly. So first off, it talks about money and it says compound at a rate of 3%. So my R is 0.03. My P, the principal, how much do I start with? That's our 500. N is how many times is monthly? How many times per year? So if you need to look back at that table, hopefully you know monthly, but you need to know those words. And so if you get that, it's going to be 12. So if I know those three numbers, I'm able to write an equation. So my equation is going to be A is equal to P times 1 plus, and then we're going to do the 0.03 divided by 12 to the power of 12 times T. So my input is going to be how many years is this happening, and I'm going to get 12 payments per year. When you put something like this in your calculator, by the way, this is an important thing. If you were to type something like this, like let's say we're going to do 3 years. If I was going to type that in my calculator, so get your calculator and practice this, you're going to type in 1 plus and then 0.03 divided by 12. Now, order of operations tells the calculator it's going to do that first. So that's okay. That's what we want it to do. And then you're going to say to the power of. Now, this next part is where this is going to make or break your problem. If you don't do this right, it's going to give you the wrong answer. So what you're going to do is you're going to say to the power of, and instead of saying 12 times 3, I don't want to do that because order of operations says exponents first, so it's going to take this and raise it to the 12th power. And then it's going to multiply by 3 at the end, and that's not the same thing. So I need to put parentheses around the exponent. So if there's more than one number in the exponent, you're going to have to put parentheses around it, or you will get the wrong answer. So make sure that you're being very, very careful with that. So to make a table and then a graph, so remember I told you that a table is just a tool. And so when we use our table to make a tool, we're using it to help us make a graph. And so we're going to put our amount in dollars, which means I'm not going to put the pennies there. Now, if this was my money and I was going to go withdraw it, I would want all my pennies. But since I'm just using this to make a table so that I can see how it's growing, I don't need to do that because it's not, if you put like $200 and 12 cents, is that going to really show any differently than $213? That's not going to show any differently on your graph. So we don't really need the pennies. We're going to label our X and Y axis. So remember we've learned that time is going to be your independent variable. And so time in this problem is years. And then the output is how much money you have. So total value of your investment. And then I'm going to come over here to my table. And so when I plug in 0, you can put this in your calculator, but a couple of things that I want you to know before you do that. When you do this, you cannot add 1 plus 0.03 because that's not 0.03, it's 0.03 divided by 12, order of operations. So don't type in 1.03 divided by 12, that's not going to be the same thing. So you're going to do 1 plus 0.03 divided by 12. Now if you put in 0, that makes your exponent 0, so it makes something raised to the 0 power. You're going to still end up with $500, which if you think about it makes sense because at the beginning of the problem we had $500. So then you're going to get your calculator, you're going to go back and replace the 0 with the 5 with a 10, then with a 15, and so on. So I want you to pause the video, I want you to go through and I want you to fill in this table. You're going to round to the nearest dollar and then come back and check your numbers and then we'll continue. Okay, compare your table to my table. And so I rounded all of those numbers to the nearest dollar. Now keep in mind you might think, well, $3,000 isn't tons after 60 years, but keep in mind that all of that you put into that was $500. So it increased a lot without you having to do anything. And so just imagine if you kept on adding to it over those 60 years, it would be a lot more money than that. So that's how compound interest works for you. Hopefully you noticed that it jumped from 30 to 40 to 50 to 60. It had gone in increments of 5 up until there, but then it jumped. So pay attention to your table and your scale of how that's going. When we go to graph this in our graph, obviously we're going to start at $500, and so that's going to be right there. And then 581, that is not that much more, it's just a little bit more. and then 675 after 10 years, so you're going to have to estimate where that is. And then you keep on going, and it's going to be rising up. And a lot of times students, they look at this and they're like, well, that's not very much. Well, it's not going to skyrocket immediately because we're not starting with that much. We're starting with 500, and so it's not that much. So be careful that you're not over expecting things. Now, make sure you pay attention to the jump right there. So I'm going to jump over to 40 before I go up to 1658. And then I'm going to jump over to 50 and go up to 2237. And then I'm going to jump over to 60 to be just above 3,000. So you see how this is not linear, and at any point in time I could check and see what my money amount was, and so that's why we're going to connect the dots, and it makes sense that it's going to keep on going. So it could just keep on going, and eventually it's going to get bigger. So if you've left it in for 100 years for your grandchildren or something, then it's going to be even more money just for your little $500 investment. Okay, let's go to the next question. So an investment of $1,000 is compounded semi-annually, so look back at your table and remember what that means, at a rate of 4.7%. First of all, it does talk about money and it does say compounded, so I will use the compound interest formula. Next thing, you need to make sure you change that into a decimal by moving the decimal 2 places left, so 0.047. Okay, semi-annually, that means twice per year, and so you need to know that. 1,000 is my principal. So what I want you to do now is I want you to pause the video. I want you to write the equation. I want you to fill in the table. You can round to the nearest dollar. I want you to make your graph. Don't forget to label your X and Y axis. And then I want you to turn the video back on and check and see how you did. Okay, here's my table. I rounded everything to the nearest dollar, and so make sure that you rounded correctly. So one thing you'll definitely have to do on quizzes and tests is you'll have to fill in a table, and I'll be looking to see that you rounded it correctly. So if you're having trouble with rounding and you don't know how you're getting it wrong every time, come and ask and I can help you with that. But if you've got something like $3.47, that's closer to $3 than it is to $4. So you would round that to $4 if you're rounding to the nearest dollar. On the other hand, if you had $3.51, then you would round it to $4 because it's closer to $4 than $3. So we're looking at that next value after the decimal to decide where to round our dollars. I labeled my X and Y axis. You should have done that too. I put my points in there from my table. So my table is just helping me find where the points are on the graph. And now I'm ready to connect those points so that once I connect my points, then I have graphed the equation that it's representing. So this graph right here is now a picture of that equation. And so that models how my money is growing. So if you look at over the course of a lifetime, it's increasing from $1,000 up to over $40,000, and so that's without you putting in any more money. Okay, the next question, again, we're going to do the same thing. I want you to pause the video, fill in your table, write your equation, label your graph, come back and make sure you did it right. Okay, so what you want to do is make sure your equation is correct. So did you get the decimal right, the 0.129? Did you put a 4 in both of those positions? You have to have that, because if you didn't do the 4t in your exponent, if you just did t, that's not going to give you the right numbers. In your table, did you round to the nearest dollar? Did you round correctly? So make sure that you've got all of those numbers exactly the same as what I have. Did you label your X and Y axis? So all of these things are potential test questions where I ask you to fill in a table, write an equation, graph the graph, label the X and Y axis, all of that stuff. So you want to make sure you can do all of that. And then once I connect my points, that is going to model the equation that is being represented. So it's going to be arrows on both ends because it does flatten out. And that's how you would do that problem. Okay, you should now be able to do the assignment on compound interest. We'll have more practice with this later on, but you're going to work on that now. Make sure you can write the equations, make a table, make a graph, do all the labeling, and then don't forget to check to see if it is compound interest. Get in the habit, because if you have multiple problems of exponential growth, you have to make sure you can identify where a compound interest problem is and where it's just growth.